Obviously in 2020 there's been a few issues with some pixels and that, so what I thought I'd do is just do some basic tests and a bit of video around that to have a look at some of the possibilities that may occur. Use two wires. You can see the red and the black up here, just slightly different strands. One's from a known Chinese vendor, the other one's Amazon purchase. Obviously the lighter wire in this case, the 17 strands, was the one I actually got from Amazon. This is really the first test that I've undertaken. It was using the lighter gauge wire. Basically after the 5th pixel I'd put a short on it to see what the maximum current capability would be of the actual wires and the actual power through a pixel. So what you'll find here is most of the power is basically comes in the through the red leads, and then at the end of the 5th pixel the actual power and ground are shorted out, and then I'm just current limiting them up to around about 20 amps, and you can see that up on the Fluke multimeter up on the top left there. And then I'm just putting a bit of a time base in that and just seeing what the outcomes were. Obviously, I'm exceeding the normal current of the cable and putting them in a fault condition, and just, reviewing those two, lighter gauge cable and heavier gauge cable. You can see up here on the clamp meter there, I've got it running at about 20 odd amps now, and we're going to have a look at the effect on the pixels. Obviously, most people have their fuses in place here of 5 odd amps, so this should technically blow the fuse, but in this case we're actually trying to look at what the limits are of the cable, therefore we're pushing it. Did use a flow meter just to have a look at some of the heating spots. Most of the heating spots, as you can see with the smoke coming off now, is actually out of the wire. The actual pixels were cold on the end, so around the LEDs and the WS2811 chips were cold, but you can see there that definitely the wires are in an overload situation, heating up and starting to melt down. So as the resistance in the wire rises because of the temperature, the current falls back a little bit to a point where an open circuit's created somewhere in the wire, a failure, and the current will fall back to zero. And the current just dropped back to zero there. Therefore, we've had a failure. So there's no longer a short present. All right, just repeating the test again using a heavy gauge wire. So this one is actually 34 strands at 0.1 of a mil. And we're just going to repeat the same test as we've done previously. Basically, if you do want to jump forward on this one runs for about 6 minutes. And all we've got is extreme heating of the cable. There was no open circuit, and we stopped it at 6 minutes, but the cable did get up to As you can see on the flare meter there, 140, 150 degrees in time. You can see the actual pixels are still cold there as well. You can see the cables coming in and out of the pixels. The flow meter, the white was set at 100 and the black was set about 20 degrees, just to try and give you a better view. Once again in that piece, you can actually see the back of the pixel quite hot. You can see the heat that's coming out of the copper cables actually radiating forward into the pixel a lot more. So this is really starting to put a lot of heat into that PCB board and the solder joints between the cable in and out of each pixel. So about 3 minute 30 mark, what the thermal camera was really showing was just the wires had kind of heated up to the point at their maximum temperature. They were slowly getting warmer, so after extended period of time, this string may have failed, but to that time limit could have been, half an hour, 2 hours, 3 hours. Ambient temperature in this situation was about 20 degrees Celsius. So obviously there is a reasonable amount of heat dissipated out of the pixel into the actual air around it. If you're in a colder climate, obviously that may extend that period of heat transfer and extend the life of the pixel before there's a possible failure. Just touching the wires there just to see. Now they're to the point where they're warmer, so warm that I can barely touch them. But they're not producing instant burns, but they are extremely hot. The pixel was quite soft at the back. Wasn't too bad compared to the front section of the pixel. All the pixels were about even in heat and the cables were pretty much uniform in heat as well. Where I'm pointing out at the moment is just this cable starting to break down, the actual plastic starting to melt away and bubble. But as a multimeter shows you, that's still passing about 17, 18 amps of current into that short. So we're really pushing this string. Okay, so this is the next test. Basically, there's a new set of pixels all set up, and what we're going to do on this one, we're actually going to take it out to about 30 odd amps and just really push them and just see how we go with the pixels. Obviously, this is a major overload situation with a high current source available, which may be possible on some systems depending on the wiring configs and sizes of power supplies and stuff like that that are feeding the strings. So you can see there after about 30 seconds, we saw one of the actual pixels break down. And what that actual fault there is it's the PCB burning up there, and it's between the input and output wires of the pixel. Same test again, just to see if I could duplicate it. This test was actually a failure where I'm touching the lead-in cable there. Basically what happened was there was enough resistance there. The clamp didn't go on well enough. It started to preheat around that resistive joint, got extremely hot, and then started to transfer the heat down through that first pixel into the second pixel. So I've just shown this, but it's just basically a failure of the test. But to give you some understanding of high resistance and the way it creates heat. And you can see the actual plastics come off. All right, just two new pixels, just slightly shorter this time, just to see how we go. This one just peaked up to a little bit of over 30 amps in current. What was interesting in this one is when the actual pixel failed, we saw the current drop right back, but then it kind of dropped back under a couple of amps and sat there, about half an amp and just continually kept arcing on the backside as it basically kept degrading or eating the PCB. And this actually went on for quite some time, which was quite an interesting outcome. You can still see there, it's actually, occasionally you see a little flash in the background of it still burning away. There's just a bit of damage. You can see that it's actually burnt through the board. I've had to cut the resin off and the case off obviously to get visibility of that, but you see quite substantial damage from the overcurrent situation.